the lion in your living room, the wolf in your den, that great beast that you pet at the petting zoo and then serve on your table. Today we'll be talking about artificial selection and how it may result in speciation. We're going to review a little bit of material from the first two lectures, but I'd like you to be able to define cultivar, landrace, and to an extent race. Relate invasive species and local adaptation to speciation. So we're going to start off with some classic examples of artificial selection, which is selection that is done not by nature or by sex, but by man. Or, well, any intelligent being, I guess. It's just that humans are the only ones we consider intelligent. And this is one of these examples right here. It's wheat. It was first cultivated in the Middle East, and what it actually is a hexaploid hybrid of 3 separate species. So, being such, it is genetically incompatible with any of the 3 species that were bred to create it. So, right there we have an example of polyploidy causing speciation, because any cross between wheat and one of these other species would be a hybrid and likely unviable. So, this being a hexaploid, there you go. You already have speciation at the dawn of its existence. So wheat would definitely be an example of artificial selection leading to speciation. Not only this, but wheat has shaped human empires. Now you might look at Eurasia and think, okay, cultivated in the Middle East, we can trade east to India and even east to China and still find good growing conditions. Like we traveled west to Rome and even as far west as London, and it can be finding good growing conditions. So the extent to which wheat could grow actually ended up determining kind of where the Roman Empire could settle, because the humans were dependent on wheat and wine, and the wheat and wine were, of course, dependent on the Roman Empire. Now, we could go into grapes as their own separate species, being selected for traits that would not make them viable in nature. I'm looking at a cat right now who's not viable in nature. Let's think about wheat cultivars. And what I want to bring out here is a cultivar is a variety of a plant made for a specific environment to give a very specific outcome. 2 cultivars of wheat that are pretty well known are spring wheat and winter wheat. This, of course, talks about when you would be planting them. You plant winter wheat in the fall or late fall, and it grows over the winter. So clearly this can only live in certain conditions in certain areas. If we're thinking the bitter cold of Canada, that's probably a bit too much and too much snow for winter wheat to really thrive under. However, it can actually survive under a certain amount of snow. So it is planted in upstate New York. Spring wheat, on the other hand, is planted in the spring and will actually be ready in the summer or fall. So what you do see here between winter wheat and spring wheat is 2 separate mating seasons, each adapted to specific environments. And if we remember this example of the skunks with their mating seasons being non-overlapping, here we can see an example of incipient speciation. These local adaptations are also going to increase the yield under a certain set of conditions. So these are wheat plants that grow best in upstate New York. These are wheat plants that grow best in Nebraska. These are wheat plants that grow best in France. And these are slightly different conditions, a cross between 2 of which would result in a hybrid that has lower fitness in either of these conditions, but could have higher fitness in a third condition that is somewhere between the 2 parental conditions. And here you can see all of the examples of 2 species that if they have a hybrid, it can either live in an intermediate environment or it cannot live in either parental environment, or well, both things can be true actually. And that kind of matches where we're going with species. So although they haven't had the time to genetically diverge sufficiently for us to really call them different species, these different cultivars are pretty darn close. Then we have corn, which is a good example of hybridization. Now, different cultivars of corn exist, and these different cultivars, when crossed with one another, can create a hybrid that is much more vigorous than either parental cultivar. So what would happen is you would take you detassel the maternal line. So you remove the male flowers from the mother. And then you would take the male flowers from the father line and just kind of bash them with pollen. No kids. And that's going to make them produce seeds that are hybrids between the 2 cultivars. And these hybrids that are coming out from between these 2 cultivars they have hybrid vigor. They are, as you see, taller. They are, as you see, having larger cobs. And these traits allow the hybrid to be better than either of the parents. Now, the seeds that the hybrid brings, however, are going to be an assortment of parental traits. Thus, very few of the seeds from the hybrid line are going to breed true as you get the segregation of certain beneficial alleles. And that's going to be a problem for the farmer, but not really a problem for the person who sells it and has to sell this F1 corn every year. You sell F1 corn every year, you're making money. If your F1 corn produces F2 corn and the F2 corn isn't guaranteed to be as high of quality, you're better off just buying new corn from the market every year. So this is a viable way of using hybrid vigor to maintain a bit of a market advantage. So, two terms to cover here for hybridizing crops are heterosis and hybrid vigor, and hybrid breakdown. Now, we've already covered hybrid breakdown, so let's look at heterosis. It's when the offspring exhibits traits outside of the range of their parents. So the two parental lines could be crossed, and perhaps the F1s are going to have larger kernels, larger cobs, and taller plants than either of the parents. Or perhaps the F1s, through the mix of the parents, have a novel trait. But hybrid breakdown can occur as well, which means the offspring actually have lower fitness than the parents. So these F2s of these rice plants here, they have lower fitness than the F1s because of the sorting of alleles when you breed the F1s with itself. And hybrid breakdown, remember, we covered earlier with speciation as a post-zygotic species barrier. So this post-zygotic species barrier right here exists between different cultivars of crops. Next, let's talk about landraces. A landrace is like a cultivar, but it also includes breeds of cattle, breeds of pigs, breeds of chickens. If you look up landraces, you can find a lot of very interesting examples of domesticated beasts that have been specially bred for specific conditions. I want to look at a few of them here. You've got the cattle group here. So this is your bovine organisms, and you have two family trees here, one from the Y chromosome, one from mitochondrial DNA, which is, of course, the paternal and maternal lines of inheritance. And you can see a whole bunch of different species, from Wisent to bison to yak to water buffalo. Everybody has a water buffalo. Two of these of interest are the guar and the yak. So you can see the guar and the yak here. These are two different species. It's actually not incredibly obvious, but one's kind of doesn't have very much hair, lives in hotter environments. That's a guar. That's a species that lives in India. Then you have a yak, which has a lot more hair and lives in colder environments. Okay, cool. We've kind of got, these are two different species. The yak and guar are related. They both have that big hump on their shoulders, but they are not the same species. Then you look at highland, and these species, by the way, the yak are in Tibet. So you have Tibet versus India. So, vastly different areas. Then you got highland cattle, which are hairy and have short horns, and they're just cute. And I think the females have horns too. Then here you have longhorn cattle, which are adapted to a hotter environment. They have virtually no hair. They have long horns. So these longhorn cattle will freeze to death under the very conditions that highland cattle will be coping with. And they live in Scotland and Texas. So geographically, these two land races are very separate. And then you have, geographically, the yak and the guar are very close. Phenotypically, the highland cattle and the longhorn cattle look very different. Phenotypically, the yak and the guar look, kind of the same. I could probably fool some people that this is just a shaved yak could be a guar. I could probably fool at least one or two people. Not anyone who's actually met them, but both of these look different, but the highland cattle and longhorn cattle are technically the same species, just different land races that have been, through artificial selection, adapted to very specific environments. So here we can see examples of how land races can look almost like different species. Last but not least, we can cover race a little bit. And race is kind of just, it's not necessarily adapted to a specific environment. You can have two separate so-called races living in the same environment with the same general with the same general conditions. The Hutu and the Tutsi, for example, were considered two different races, and in as much as they would actually try to exterminate one another. But they live in the same conditions and are relatively both adapted to the same area. So that is even less of a difference than between two different breeds of cattle. And races, really, it's not that incredibly different. It's more recent adaptations. So anyway, what about bringing a species back from extinction? So we talked a little bit about speciation and all of that, and hybridization. Well, hybridization in reverse. So this is the aurochs, and it went extinct. It was extinct because it was bred into a whole bunch of different cattle species. So people would take their cows, out to the pasture next to the large, deep, dark, scary forest. And the large, deep, dark, scary forest might have an aurochs living in it, or a nearby plain might have an aurochs living in it. And the aurochs would, since they're almost to extinction anyway, they'd see one of these cows just kind of grazing on her own, and well, they would do the thing bulls do best. They would mate with it. It's not like a human's going to stop them. I mean, look at those horns. So they'd mate, and the genetic material would then be in the sired offspring, which could actually be more adapted to the local environment. So this more adapted local landrace that has just a touch of aurochs now contains some of the genetic information of the aurochs. So what do? Well, you selectively breed these separate landraces together, and breed out the cattle and breed in the aurochs until you get an aurochs back, or use a little bit of genetic editing to get the aurochs back by just segregating the genes back. It's like Jurassic Park, but an incredible amount of cow mating. So it's a cool idea, a cool hypothesis, and perhaps possible. All right, last bit, invasive speciation. So this is it's a bigger concept that I'm going to cover less of. Invasive speciation is the idea that an organism can go to a new place and then genetically separate from the ancestral population to the extent where their local adaptations would be diluted by any breeding with the originals. So this is a cat. So what happens is you have cats, and they are desert animals native to Egypt and surrounding environs. So that's a desert. That's a hot place. This is a Norwegian forest cat, and he looks just like he brings doom upon the world, but they're actually really cuddly. Or we have the Maine Coon, and these are they're ultra floof, and they're very friendly, and they like the outdoors a lot. They can survive in the taiga. Desert to taiga is not exactly a quick and easy transition, so it takes a lot of local adaptation. Cats are an invasive species. They destroy local biodiversity, so it's entirely possible that this Norwegian forest cat, if humans were to go extinct tomorrow, would continue to wreak havoc on local bird populations. So Norwegian forest cat, Maine Coon, perhaps a cat could be introduced to Alaska, become the Alaska floofy devastator cat or something, and it could be locally adapted. The problem is you breed that with a Felix sylvestris from Egypt, and their offspring are not going to be good Egyptian cats. They're too hot. And they're not going to be good good Alaskan cats. Too cold. So the hybrid between them will have lower fitness in either environment. Of course, there are plenty of intermediate environments between desert and taiga. But if humans went extinct, these would be genetically isolated groups too. There is no way a Norwegian forest cat is going to migrate, into Denmark. They're not going to swim. They're not going to cross the ice. Cats are lazy. So they'll be genetically isolated, and that could lead to reproductive isolating mechanisms such as very specific breeding behavior. Remember, I said these cats are actually pretty gregarious and friendly, whereas other cats can be feisty and really spiteful and hate-filled. So these reproductive isolating mechanisms could mean that the invaders could become new species. If humans were to go extinct tomorrow, the remaining cats could survive in the wild pretty well. We know this because we've seen it happen when they drive a lot of other species to extinction. And these invasive species could then become new species of their own, creating an adaptive radiation of felids across the world. So things that will make a species particularly invasive, combined with things that will make a species able to be locally adapted, combined with any genetically isolating event, will lead to an adaptive radiation. And here we can see all of these things summed up in a delightful